Hello, in this video, let's look at two key facts that we often see in trigonometry. The first one is that if we look at any triangle, whether it is right triangle or any other triangle, the angles will always add up to 180 degrees. That's the first fact. The second fact is if we have the right triangle, and only if we have right triangle, then we also have Pythagorean theorem, which says that the square of the longer side, which is the c, is equal to the squares of the shorter sides added up. Now let's look at each fact and see if we can perhaps justify it to ourselves, even intuitively. It will be better to have some idea of why it may be true as opposed to just memorizing. So let's look at each. So the first one is we have that the sum of the angles is going to be 180 degrees. So let's begin with a box, just a regular box which has four corners and each corner is 90 degrees. And if we add up all the angles inside of this box, we're going to get 4 times 90, which is 360 degrees. So inside of any box, the angles will add up to 360 degrees. But if we cut this box in half, exactly in half, then half of the box is going to have 180 degrees. And even if we imagine ourselves picking up this triangle by the corners and moving the corners in such a way that one angle gets bigger, then whatever one angle gains, the other angles lose, and the sum will always stay 180 degrees. So that is why the sum of all the angles in any triangle will always be 180 degrees. Now, for the Pythagorean theorem, we need to remember that the area of any box is length times width. So if we have the box that has right angles, then the area is length times width, or base times height, depends on how we name our sides. And if we look at our box with base times height and we cut that in half, then the area of any triangle, of any right triangle, is half of the base times height. And we will use this fact in our justification of Pythagorean theorem. So there are many ways online that show how Pythagorean theorem is true. There are many different proofs and justifications, so this is just one of them, and it is geometric, so it may be easier to see visually. Now here we have a square. The length and width are exactly the same, and inside of that square is a smaller square with, again, the length and the width is the same, and for the smaller square we will name the sides C, and for the bigger we will have the longer side is named B and the shorter is A. So when our corner cuts the big side, the shorter piece is A, the longer piece is B. Now let's come up with the area of this big blue box, a square, and we will come up with it two different ways. And since we are describing the same exact area, our two different ways should give us the same answer. Way number one. Well, the area of the box is the length times the width. And what is the length of our box? Well, it is A plus B. That means A plus B squared is the area of our blue square. Also, we can do it a different way. We can say that the square is made up of the small triangle, which is, again, length times width, which is C times C, plus we also have 4 smaller triangles inside. And each triangle has the area of 1/2 of the base times height, and the base is B and the height is A. So how many of these triangles do we have? Each one has this area, but we have 4 of these triangles, so we will times this by 4. Now let's simplify and see what comes out. If we square a plus b, we can multiply it out if we wish. A plus b equals to c squared. Now 4 times half is 2. In other words, 4 divided by 2 is 2. So plus 2ab. Now when we multiply the left side, we get a times a, that's a squared, a times b, that's ab, then another ab, and then the b times b, which is b squared. On the other side we have c squared plus 2ab. Now in the middle we have ab plus ab, and that makes 2 ab's plus the b squared is c squared plus 2ab. And we can see that on both sides we have 2ab, and we can subtract it from both sides, and they will cancel off. And what is left? What's left is exactly a squared plus b squared is c squared, which is the Pythagorean theorem. So this is one way to show how the Pythagorean theorem might be true, and it is only going to work if the triangle is right. If we try it on any other triangle, we will not get the right answer, and that's very important. So these are the 2 facts we often see in trigonometry, and that's the general justification of them. Now, when we study math, we may either try to memorize all the formulas and steps, and we can try to aim, or we can try to understand how and why. The understanding route will take a little bit longer initially, but it will eventually save us many hours of time, and it will build up confidence for the homework and the test. It will reduce math anxiety, and overall grades would also be considerably better if we spend more time on understanding how and the why than just simple memorization of the steps, formulas, and procedures. Yes, it's true, sometimes we do have to memorize formulas and other things. Just like in any subject, there are some keywords, key terms that have to be memorized. Otherwise, reading anything in that field would not make any sense. So we have to know some words and we have to know some formulas. To memorize them, one of the best ways, the most effective ways to do that is to actually write them out over and over on a piece of paper. It is more efficient to write things over and over than it is to simply read them in a textbook or watch a video, or even making flashcards is not as effective as writing things down. Because when we write things down, we create many more neurological pathways than if we simply look at things or if we look at flashcards. So it is a better strategy overall to spend more time initially on understanding and then build on that. And that's it for this video. That's the 2 key facts that we will see. And if you have any questions on anything, please let me know. Thank you for your time. Take care.